Okay, this is the Temasek Secondary School Physics Prelim paper 2014. We are going to start with paper 1. So this paper is not an easy paper. It's not an easy paper, especially if your mathematics is not strong enough. Okay, it involves a lot of algebra manipulation and interpretation of graphs. So I have also received feedback that you all do not can't really see the words on the question paper in my previous video. So now that I received the feedback, I decided to zoom in a little bit. So let's begin. Okay, question 1 is your standard measuration question. The trick is that you need to remember to divide by 2 because what you are measuring is the diameter. So when you are calculating the cross-sectional area, you need to divide the reading by 2 before you plug it into your pi r square formula. For those of you who are still unable to read the screw gauge correctly, this is how you do it. So first you read from the main scale. So this is 5 mm. This one is not 6 mm, this is 5.5 because one rotation on this sleeve will give you 0.5 mm. So that's why here is 5, 5.5, 6, 6.5, and this is 7. So that's why on your main scale you will have your 7 mm. Then after that you read from the sleeve. So this is 15. You need to read the reading that is aligned to this line on the main scale. So this is 15, 16, 17, 18. And this 18 is actually 0.18 mm. So main scale 7 plus this 0.18, you will get 7.18 mm for your diameter. And then you divide by 2, use your pi r square, you will get your cross-sectional area. Okay, for your question 2. Question 2, you were told the frequency. That means you can work out the period using t equals to 1 over f. So you know that for one oscillation it requires 2.5 seconds. So 30 oscillation is just multiplied by 30. Okay, question 3 will begin to be more difficult. So question 3, you were told that a ball dropped from an unknown height. You do not know how high it is, but the question tells you that it takes 1 second for the ball to hit the ground, and then upon touching the ground it created a depression of 8 mm. So be very careful, this is 8 mm, so when you convert this to meter later, this will become 0.008 meter. Okay, so with this you would like to try the energy conservation approach, because they tell you the depth of the impression, meaning that you can use this information and you can calculate the work done. And because work done is equals to F times D, by knowing the resultant force acting on the ball upon impact, you can then calculate the deceleration. Okay, so there's a lot of way to approach this question. Some of you may think that, oh, I have to find deceleration, so I have to find the net force, and then you got stuck there. So if you know that, okay, I need to find deceleration, I need my net force, then you see this information giving you some distance. Then you should think through in your mind, is my net force direction and the direction of this impression in the same direction? Why do you need to check whether they're in the same direction? That is because your work done formula requires you to have the F, the force factor, and the distance to be in the same direction. So that's why if you see that these two things is in the same direction, it is a hint to you that you should use the work done formula. So if you are using work done formula, then that means you need to approach this question from the conservation of energy angle. So with that, that means you need to know what is your total energy. So how do you find out the total energy? You need to know what is the initial potential energy that the ball processed, because at the beginning the ball is at rest, meaning that the only energy that the ball processed at the beginning is your PE. So in order to find the PE, you need to know the height. So how do you find the height? Okay, the other piece of information given in the question is it takes 1 second for the ball to reach the ground. So using this information, what you can do is that you can sketch out a very rough sketch of speed time graph. So you know that at the beginning, the ball does not process any speed, right, or velocity, so it must begin at 0. And at 1 second, okay, because the question tells you that ignore air resistance, that means your acceleration is going to be uniform, and that acceleration has to be 10 meters per second square. So within 1 second, the ball is going to accelerate to 10 meters per second. That is the definition of acceleration, right? So knowing this, you manage to sketch out a very simple VT graph. So what is the distance that the ball travel within these 1 seconds will be this area underneath the graph. So to calculate this area underneath the graph is quite simple, right? It's just your triangle. So from this sketch, you found that, oh, my ball actually fall down from a height of 5 meters. Then you use your conservation of energy. Okay, let me zoom in a little bit. Then you can say that, okay, initially my potential energy must be equals to the work done, the ball dissipated when creating that impression of 8 mm. So let's write down all the formula first. I have mass mgh on the left hand side, and I have force times distance on the right hand side. And I know that this force is the net force. So this net force, I can break it down into ma. Now some of you who do not have this habit of writing down the algebra first, you all may be worried like, oh no, I do not know the mass, I cannot use this approach. Now the thing is, if you do not try out your question and then tell yourself that, oh, I can't find the m, I give up, then you are actually not tackling the question. So what I did at the beginning, I'm also quite worried. I do not know the mass. Am I going to get stuck using this approach? But then I tell myself, okay, why not just give it a shot first? So if you see here, my net force, when I expand it to mass times acceleration, you will notice that the left hand side and the right hand side have this m, and these are this is the common mass, right? Because you only have that body. So because everything is multiplied together, you can actually cancel the m. So what you're left with the left hand side is just gh, and right hand side is just ad, acceleration times the distance. So since you are interested in finding out the acceleration, you move the d over here and make a the subject. Then you realize that on the left, you know all the values of all this algebra. G is your gravity, is 10. H you have calculated here, which is your 5. And the distance is that tiny impression that created in the sand. So you already know that is your 0.008 meter. So with all these things, you will be able to calculate what is your A, your acceleration. Okay, so you will get your answer C. Okay, for your question 5, you need to know how to read your graph. Okay, so do not worry. Reading graphs, what is the trick in reading graph is identify some key coordinates, and then use those key coordinates and check against the ABCD and see if it fits onto the graph. So first we look at the context of this question first. So it's about a tennis ball falls freely downward. Freely downward, the word freely indicate that you can ignore your air resistance. It means that you should be expecting constant acceleration or deceleration. Okay? And when the ball is actually falling, meaning that initially the speed of the ball must be 0, 0, right? So you know that at time and velocity, if you want to plot down some key coordinate, you know that, oh, okay, at the beginning, at time 0, my velocity must be 0. So you got your first pair of key coordinate. Then it tells you that, okay, the ball hits the ground, meaning that at some time, okay, at some time, I do not know what is that, let's call it T1. The velocity of this is going to peak because it hit the ground. And the next moment, after it peak, is going to suddenly change direction. That means from positive to negative, or from negative to positive, because it's going to bounce back up. Okay, so there's a sudden change of velocity in terms of the sign. Positive change to negative, negative change to positive. Okay, then after that it's going to bounce up to the maximum height without loss of energy, meaning that the area underneath the graph before it bounces, when it's dropping down and bouncing up must be the same, meaning that at this t, okay, the graph has to be symmetrical. So just by reading the context of this question, you can actually deduce some of the property of the graph that you can make use of. So let us look at all the options. So the first information you know is that the graph must start at 0, 0. So you can already eliminate A, you can already eliminate C. In fact, you can also eliminate D. So just by the first information, you can actually tell that the answer is going to be B. Okay, but for the sake of going through, let's examine the other deduction that we have and see whether this check in with our option B or not. Okay, so you know that at some time t, when it hits the ground, the velocity is going to be peak. And not only that, because it is going to bounce back up, it's going to have a sudden change in direction. So instead of the velocity factor pointing down, when it hits the ground and bounce up, the velocity factor is going to be up. So from down, suddenly change to up. So you see here there is a sudden change of sign. And after that, the ball is going to bounce up, and as it goes up, it's going to lose speed because as the gravity is pulling it down, so it loses speed until it reaches the maximum point, whereby you see the area underneath these two lines, they are about symmetrical. So everything checks in, so B is your answer. You have made no mistakes. So that's how you tackle this kind of question. Okay, now for your question 5 is just tedious. Okay, and you need to be very careful with the information given in the question. So you are asked to find the density of this unknown liquid. Okay, so a few things you need to take note. It says when it is filled up with an unknown liquid. What is this it? Okay, this it is actually referring to your bottle. Okay, so this it is your bottle. So basically, your bottle is filled up with this unknown liquid and it has a mass of 50 grams. So if you were to find out what is the density of this unknown liquid, you already know what is the mass of this liquid. Plus the bottle, of course. This mass 50 grams is actually the unknown liquid mass plus the bottle's mass. So you need to be careful with that. And how do you find the volume of the liquid? Oh, that is simple because your unknown liquid has filled up this bottle. So basically you also need to find out what is the volume of your bottle. Okay, so let's tackle this one step at a time. So how to find the mass of the unknown liquid is just your 50 grams, but this 50 grams is the bottle plus the unknown liquid. So you need to minus off this 20 grams here. So the mass of unknown liquid is actually 30 grams. So some of the students will make a mistake here. Okay, then how do you find out the volume of the bottle? Okay, the other piece of information given to you is the density of the water. So you can find out from this the information given here, what is the mass of the water. Okay, you just need to take this 150 grams and minus off the empty bottle. You can find out what is the mass of the water. Okay, from the mass of the water and the density here, you can then find out what is the volume of the bottle. Or should I say you can find out what is the volume of the water, which is equals to the volume of the bottle. So once you know the volume of the bottle, you can put it into here. The volume of the bottle is going to be equal to the volume of unknown liquid also. So once you have these two information, the density is just mass over volume, you can find the answer. Okay? Okay, question 6. Question 6, even for me, I make a mistake. Okay? So how do you tackle this? Like I said, this paper requires you to play a little bit with the mathematics. So let us look at the question and I bring you through the thought process of how to tackle this. So you were told that a cylinder is placed on a mass balance and then you are pouring some liquid into the cylinder and the mass balance basically gives you a reading of the mass. Now notice that this mass is the mass of the liquid that is being poured in. Okay, and this mass is inclusive of the bottle, right? This mass is not just the liquid that's being poured in, it's the mass of the bottle plus the liquid. So even if you have no, I don't know how to pronounce this, if you do not have this substance poured in, will there be a mass? The answer is yes, right? Because the setup is like that. If I draw out the setup, it will be easier. So the question is saying that, okay, I have a mass balance. Okay, this is my mass balance. Okay, there's a reading here. And then after that, you put a bottle on top, a cylindrical bottle, and then it start pouring in some liquid. So my question is, when the height is 0, will there be a mass? The answer is yes, right? Because the bottle has some mass. So again, you need to identify some of the key feature. So key coordinates. So if you have h against mass, so even if h is 0, mass is going to has some value. Yeah, it cannot be 0, 0. Okay, the next thing. Now, the question already tells you that it's going to be a cylindrical cylinder. Then you need to deduce what is the relationship between M and H. So, how can I find a relationship between M and H? Now, the only physics quantity that in your syllabus that relates mass to a certain geometry is density, because that density relates mass to volume, and volume is your geometrical parameter, right? So let's try. I'm just trying also. When I look at this question, my mind is blank. I do not know how to start. I have no idea how to tackle this. It's not like I have one glance and I got the answer. So I tell myself, okay, let's try the density formula. So I write down the density formula. Okay, D equals to M over V, and I know that, okay, the shape of the container is cylinder, so I can find out the volume pretty easily. So the volume will be given by pi r square h. That is your cylinder formula. Okay, then I ask myself, okay, let's look at this. Okay, look at this. I have mass here, I have h here. It seems that I can make a relationship out of this. So what I'm doing is that I'm just separating this whole chunk of fraction into two fractions. Okay, so that I have this m over h, which is of my interest. Then I ask myself, pi r square, this r is fixed, right? Because the container radius is going to be fixed, and pi is actually constant. So this whole chunk of 1 over pi r square is actually just a fixed number. So I convert it into a constant k here. Then I ask myself, density is also something fixed. It's just a value. It's a property value, right? As long as I'm using the same liquid, D is going to be the same. Okay, so let's move everything, all the constant number to the left. So that's why I move my k over here, I get D over k. Then I tell myself, okay, so D over k, constant over another constant, is going to be a constant. So I will know that, m over h is actually equals to constant. And what is m over h? So if you look at the graph, you have the mass on the y-axis and the h on the x-axis. So in this case, the m over h is actually your gradient of a graph. So I know that, okay, my gradient has to be constant. I know this second piece of information, so I look at all the options given to me. Gradient has to be constant. I can already take out B and D. Then I tell myself, okay, so what is going to happen? Will there be a mass when my h is 0? So when I first do this question, I was so carried away by this discovery that I thought that this mass only refers to the liquid. So I told myself that, okay, so if there's no liquid, when h is 0, there's no liquid, right? Mass must be 0. But then, by reading the question again, you will notice that, actually, this m here include the mass of the cylinder. So meaning that even if the h is 0, my m has to have certain value. So that's why your correct answer is C. Okay. Now, question 7 is about your Newton third law. And Newton third law, most of you remember Newton third law with in 2 key points. Most students, they remember it as the force magnitude must be the same. So 10 Newton here, 10 Newton here. And the force must act in opposite direction. So most students remember Newton's third law as these 2 key points. That is wrong. Okay, the third part of Newton's third law states that it has to act on opposite bodies. Meaning that, let's say, the forces of, let's say, the weight of this human, So I'm giving you an example. So the weight of this human is from where and is from which body on which body. So the weight of this human is actually from the earth on the human body, right? Correct. So I write down the sub short form of the earth on the human body. Now by Newton's third law, okay, an action and reaction pair must be, now that I have earth on human, the reaction pair must then be human on earth. Okay, these two pair of cause and effect, that means earth on human, must be reversed, human on earth. Then we consider this an action and reaction pair. If you are telling me that, okay, the weight is earth on human, but you tell me that, okay, I consider the normal contact force, that means the contact force, the force of the box supporting the human, is this weight and this normal contact force an action-reaction pair? The answer is no. Because you see here, the weight is actually from the earth on the human being. Earth on human being. But down here, the normal contact force is box on human. Box on human. So you see, this is earth on human, box on human again. So if both are on the human, it cannot be an action and reaction. You see, the key thing here is that the subheading here must reverse for it to be considered as an action-reaction pair. Okay, so with this understanding, let us analyze the option that is given here. So the first one is the weight of the man. Okay, so the weight of the man is actually your earth on human. Right or not? Then after that, it gives you the second force is the normal force from the box supporting the man, which is what I have given you, is the normal contact force from box on human. So both are acting on the human. It is definitely not an action-reaction pair. So that's why I put a cross at the end. The next, they tell you again the weight of the man. So again, W-E-H, earth on man. And then the other force they give you, contact force on the box by the man. Okay, so you have a contact force on the box by the human. So you see here, this is earth on human, this is human on box. The subject here is different. Now one is on human, one is on box. One is earth on human, the other is human on box. So obviously this is not an action-reaction pair. So look at the third one. Again, weight of the box. Weight of the box is the earth on the box. Earth on box. The next force that they give you is normal force, okay, from the ground on the box. So from the ground, G on the box, GB. So you see here is both of these forces are on the box. So if both forces are on the box, then definitely not an action-reaction pair, right? One is EB, the other is GB. It's not like they flip. Okay, so let's look at the last one. Last one is weight of the man. So this is earth on human. Then after that, gravitational force of man on earth. So it will be gravitational force of the man, that means the human, on earth. So you see here, one is EH, one is HE. So yes, it is a action-reaction pair. So that's why D is correct. Yeah? Okay, question 8. Question 8 requires you to read the graph again. And like I said, the key of reading the graph is identify a key coordinate. So down here, they ask you to compare, comment on the mass and inertial of block B and block A. So how to find the mass? So down here, you see that a series of force, blah, 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 on a smooth surface. Okay, so on a smooth surface, it's telling you to ignore friction. So meaning that the force here that it is applied on the block will be your net force. That's the only force, because you do not need to consider friction anymore. So using your formula F equals ma, what you need to do is just find a convenient coordinate. So down here I find a convenient coordinate as 1, 1. So with that, substitute into your formula, you can deduce then what is the mass of your block. So I do that for both the block A and block B, and I found the mass. So with this information, I can already eliminate A and B. Yeah, because the mass of B is twice of the mass in A. So that's why I choose B and D. Then now I need to determine the inertial, and you know that the inertial is only dependent on the mass. So if the mass is twice as large, the inertia is going to be twice as large. So that's why your answer D. Okay, question 9 is a bit tedious again. Like I said, it is tedious, but it is not difficult. Now, they ask you to find the density of the wood. Okay, but they didn't tell you anything about the mass. Okay, you can find out a little bit on the volume because it is a cylinder. Okay, but they tell you no information about the mass, meaning that you have to look at this diagram. This diagram is a rod being balanced on a pivot, and then that means that you have to use the principle of moment to calculate your weight, and then after that calculate the mass, and then from the mass you can then deduce what is the density. So like I said, it involves a few steps before you can conclude which is the answer. So if you look at this pivot system, number one, what you need to know is that the weight of the wooden section and the weight of the rubber handle has to act at the center of gravity. So let us look at the mass of the let's look at the weight of the wooden section. So when you look at the wooden section, you should only consider this length, the 4L. So since it is 4L, the CG will be at 2L from this end. So you know that, okay, the weight of the wood must act at this point, 2L from here. Okay, then after that you look at your rubber handle. Rubber handle, you only consider it as a separate part, and it will have a certain weight as well, right? And this weight must act at the center of gravity of just the rubber handle, which is 0.5L from this end. Now, because this whole stick is balanced, right, is in equilibrium, meaning that the moment from the wooden handle, the weight of the wooden section must be equals to the moment caused by this, the weight of this rubber handle. So because you are going to use the principle of moment, then you need to find out what is the length from the weight to the pivot. So this one is just a bit tricky, but you can do it if you draw it out. So this is how I do it. I know that this is 2.1 L, this is L. So I just take this minus this, I can find out what is the distance here. And I know that my WR is going to happen at half L. So with this, I know that the distance between pivot to my WR is 1.6 L. So that's how I get my 1.6 L here. Okay, this is the moment created by the weight of the rubber handle. Then next, once I know this is 1.1, I know that this is 2, and I know that the whole length is 4. So I take 4 minus of the 2L minus of the 1.1, I can then find out that, oh, okay, the distance between WW is 0.9 from my pivot. So that is how I get my 0.9. So once you have this parameter, you can then use the principle of moment, and then you can find out until here that you have this equation, 0.9 WW equals to 1.6 WR. Now your target is to find the mass of the rubber handle. So WR is your target. You have to do something to WW so that you can expand this. So looking back at your question, you will notice that they give you the density of the wooden section. So let us start making use of this information. So I know that the volume of my wood is just the cross-sectional area times 4L. Now, again, although I do not know what is the value of my cross-sectional area, it doesn't stop me from trying. Okay? Don't stop trying. Just put some algebra into this, and then we see if this algebra would eventually be cancelled somewhere somehow. Just try it first. Okay? So then I can then tell myself, okay, I know the volume. I can then use the density given in the question, and I can find the mass of my wood. Okay? And I did. So I used density multiplied by the volume. I know my density is 1.01. My volume here, although I have some algebra, is okay. Just do it. So I will get the mass of my wood in terms of 4.04 Al. If I know the mass, I can find out the weight, right? So from here, I find out the weight of my wood. So now that I know the weight of my wood, even though I have some algebra here, it's okay. Just take it as a value, okay? Then I can tell myself, oh, in that case, this WW, the weight of the wood, and this 40.4 Al, I can do a substitution. So I bring in my 40.4 Al and I put it in here. So then I realize that, okay, so let's expand this. I will get 22.725 Al. So now I still got this Al which is bothering me. But it's okay, let's keep on trying. So now if I want to find, because I need to find the mass, right? So I have now the weight of my wooden handle. If I want to find the mass, I just divide it by 10. So that's how I get the 2.2 something. I just divide both sides by 10. So my weight will become my mass. Okay, so now the question wants me to find density. So density will be the mass of the rubber handle divided by the volume of the rubber handle. So let's try to divide it. So if I divide the volume by, if I divide the equation on the right hand side, I have to do the same thing on the left hand side. So the volume of the rubber handle is just the cross-section area multiplied by this length, right? Al. So the volume is just Al. Then I realize, oh, okay. Now the Al seems to be able to cancel off each other. Yeah, so I just cancel off each other. Mass over volume will get my density. I get 2.27. You see? So, moral of the story, don't stop your approach if you do not know the value of some unknown algebra. Just give it a try first. Maybe in your working, the algebra will just cancel off and you can just ignore it. Okay? Okay, question 10. Question 10 required you to really think through. Okay, you have to be able to visualize the movement of these two blocks, big M and small m. Okay, so one of the key information given to you is that the block is moving at constant speed, meaning that no acceleration. Okay, and you have to deduce which statement best describe the motion of the block. Okay, so let's draw out the forces. Okay, of course, the obvious one is that there will be weight here. The weight here will be mg, pulling it down by gravity. And then, of course, there is a tension here. Okay, that's about it for the forces acting on the small m block. Then if you look at the big M block, you will have the force that is pulling onto the big M. So this force, because this is the same string, right? So within the same string, there can only be one force. If not, if one force is bigger than the other, the string is going to be torn or is going to slack. Okay, so we assume that the string is taut. That means it's straightened. Okay, that means this force pulling M over must be equals to the tension that is holding M. Okay, then after that you will have friction, because they didn't mention that it is a very smooth surface, so there's friction. Okay, so with this understanding, let's look at the statement. Both blocks have the same mass. Now the thing is that you can't deduce this because there's simply not enough information. Unless they tell you what is the friction and all that. Okay, so from just A, I am not sure whether I can deduce it, so let us not consider this first. Okay, then let's look at B. The weight of the block M must be equal to the friction of the block. So if you see here, if you look at the relationship of all these forces, because the whole system is moving at constant speed, it means that there is no net force. No net force means that my downward force must be equals to my upward force tension, right? So I know that mg must be equals to Tm. So if Tm is equals to mg, and because the whole system is moving in constant speed, meaning that my friction, which is equals to Tm, must then be equals to my mg. So therefore my friction is actually equals to mg, the small mg, and this small mg is actually the weight of the small m. So I know that, okay, B is correct. I can mathematically prove it. Okay, then after that you look at C. Acceleration equals to the weight of the block divided by its mass. There is no acceleration. So you know that C is wrong. The tension pulling the small m block is larger than the tension pulling on the big M block. Now what I want you to imagine is that, imagine now this tension and this tension are not equal. What will happen? Either the string will break apart because the upper end of the string is under a larger force than the lower end. It just simply cannot happen. Okay, the force is going to redistribute itself along the string. Okay, so you know that your D is wrong. So it confirms that B is correct.